Thank you, and good afternoon, good morning, if you are in Belém. We are just starting the COP30 now. I'm following my Brazilian colleagues in Belém with the opening session with President Lula now speaking. So it's the official kickoff of the COP30 today, as you may know. This webinar is focused on specific questions on blue carbon and mCDR, but before that, I would just like to introduce why we are here, basically, and why this is important now. So, when we created together with a bunch of NGOs, the Ocean Climate Platform, in 2014, the ocean was not an issue for climate negotiations. Then progressively, ocean entered to the discussions and to the dialogue and to the action plan of the UNFCCC. And we are seeing now various streams of work on the UNFCCC concerning the blue agenda. We had the Blue COP in Madrid 6 years ago. So the Ocean Climate Platform continue its action to follow this blue agenda inside the climate talks. And the Tidal Ocean Foundation is progressively working more focus on this issue of blue carbon, taking a position about that developments, and we are following with some concerns and some questions. The push for blue bonds and the push for blue carbon apply to the ocean. So this webinar has the aim to focus on this issue, which is important as the carbon market is now back and Europe is now trying to push what we call the emissions trade system, which allows states to compensate its emission on blue carbon projects, basically. So this COP30 is most focused on implementation and, of course, bring back the momentum for climate action, despite the complex geopolitical moment we are living. So bring back the momentum for climate action, focusing on implementation of the Paris Treaty, focusing on bringing back action for the Paris Treaty. Despite that, the ocean agenda, it's still very present in Belém. We have an ocean pavilion, virtual. You're invited to follow. We have many ocean events. The issue about the Amazon plume, which its oil exploitation, it's also very political for Brazil and for all of us. But here we are focusing on the blue carbon and the mCDR techniques. I have the pleasure to invite now Martin Alessandrini with the Tidal Ocean Foundation policy team to present a bit the framework for regulation of these techniques. But maybe before we start with Victor, I'm sorry for that. So Victor Brun, the science lead of the Ocean Climate Platform, will set the scene, actually, Victor, and after we are going to the frameworks with Martin for regulation. Victor will set the scene with description and recommendation of different techniques now that are being presented as alternatives for enhancing the capacity for the ocean to capture the carbon. So please, Victor, the floor is yours.
Thank you very much, André. And I'm sorry, we'll have to deal with me first, even though Martin is a better speaker than I am. So good morning, good afternoon, good evening to all of you. It's a great pleasure, and thank you very much, the whole Tara team, for organizing this, because I think it's a very interesting and urgent topic to talk about. So just a few words to set the scene and to explain what we talk about when we talk about marine carbon dioxide removal, or mCDR for short. The first thing I would like to start, I'm sure most of you are aware of it, but I think it's important to start the conversation with this. It's the role of the ocean to capture and store CO2 in the long term. So I'm sure all of you are aware about 1/3 of anthropogenic CO2 emissions have been absorbed by the ocean, who's a good friend to us and who's been helping us a lot in the fight against climate change. There are two main mechanisms for that. We have the biological carbon pump and the physical carbon pump. So just in a few words, the biological carbon pump here on the left uses or is based on the phytoplankton, so all the little plants that live on the surface of the ocean. And through photosynthesis, some CO2 will go from the atmosphere to these plants, and some of it could then fall and be deposited in sediments. And so some of the carbon will go straight from the atmosphere then to the bottom of the ocean. And then we have the physical carbon pump, which is physicochemical and based only on the dissolution of the CO2 that goes in the surface layer. And then it's based on the fact that some currents are bringing this CO2 to the bottom of the ocean. So it's two complementary mechanisms, but that are happening in very different ways. And something that maybe is a little bit less known about this phenomenon is the fact that the biological carbon pump actually has been much less efficient at capturing anthropogenic CO2 emission. So it's a system that is already more or less at the equilibrium. And to put it simply, because it's still something that is not so well understood, but most of the CO2 emissions that have been produced by humans have been captured by the physical carbon pump on the right. That is not to say that the biological carbon pump is not important, because if disrupted, then it could diminish in terms of ability to capture CO2 in the ocean. So it's something, of course, to keep in mind. It's a healthy biological carbon pump that captures CO2. So that being said, now, and observing this, people, some scientists in the 80s approximately, have been starting to think that we could use these processes and capture even more CO2. And that's when we talk about marine carbon dioxide removal. So the goal, to put it very simply, is to use ocean processes to capture even more CO2 than what it already does for sometimes a short period of time, or if possible, a very long period of time. The goal being, of course, to mitigate climate change and all the deleterious impacts it can have on biodiversity and humans. So this is a little bit of an overview of the different techniques that we are talking about. On the left here, you can see the blue carbon restoration. This technique, I would say, is a bit different from the others for a few reasons. The first reason is that it's the only technique among all of these that appears to be technologically ready, meaning that, for example, we know how to plant mangroves. For seagrass, it's a little bit less the case, but we know that it more or less how to do it, and we know that it's quite safe if done properly. For all the other techniques, we have a lot of uncertainty. So there are risks. We don't know exactly what could happen. We don't know if it can work, but we do know that it can come at the expense of marine biodiversity and humans. Also, one of the difference we can point is the fact that blue carbon restoration has a tiny potential, actually, when it comes to mitigating CO2 emission. The amount of CO2 it could actually capture and store is very limited. So that's one of the most important things I wanted to put here is, on the one side, we have blue carbon restorations, and then we have a lot of different techniques that are all more or less experimental in early stages and not at all ready for implementation, or even to put it in some projection, trying to think of how much in the future we should be able to capture with these techniques. Very experimental. Now I'll go very quickly through the different techniques just to give you an overview of what we talk about. In terms of biological approaches, we have blue carbon. We also have macroalgal growth. The goal is to cultivate macroalgae in large surface, in large areas of the ocean, and then either sink this to the bottom of the ocean, which could have implications and impacts on the life in the deep ocean, or to use this, for example, to make biofuels or something else. Then we have phytoplankton growth. This one is a bit more famous because it includes iron fertilization. There have been already a few experiments of iron fertilization, not very concluding for most, because it was really hard to track what would happen. And so the goal of this is to fertilize the ocean and create some blooms of phytoplankton. So kind of boost the productivity of phytoplankton and hope that more of this phytoplankton will fall to the bottom of the ocean, hence capturing CO2. The experiments that happened actually couldn't really track what happened with this phytoplankton and to test at all if it could capture more CO2. So in the same way, we don't really know if this could be efficient. Then we have two chemical approaches. One is direct ocean carbon capture. It's quite similar to something a bit more famous, which is direct air capture or DAC, but it's based in the ocean. It's even less technologically ready and more expensive so far than direct air capture, but it's still discussed as an option. And some people say that it could be a bit safer than other kind of techniques because it happens more in a closed system with a better control of what comes in and what goes out. But of course, it's still heavily discussed and it could come with a lot of different impacts. And finally, we have ocean alkalinity enhancement. This one, the goal is to use alkaline materials, so basic materials such as silicate rocks like olivine, to crush it and then to disperse it in the ocean. So it's some kind of sand. And the chemical reaction of this sand would actually capture CO2. So it's simply the sand would bind with CO2 and it would leave some space for the atmosphere to release CO2 back in the ocean. So that could be a way to store quite permanently, actually, some CO2. But of course, that would come also with a range of different impacts in terms of pollution, in terms of changes in the pH of the ocean. So that's also something to consider. So that's it for the overview of the techniques. Bear in mind that it's a lot of different techniques. We talk about a lot of different things, but put quite simply, that's more or less the groups of techniques. With the Ocean and Climate Platform, seeing how difficult it was to communicate in this topic and how much disagreement there was even within the scientific community, we decided to organize a series of workshops. And so we had some researchers come in, along with policy experts and some other members from our network. And we worked with them to first set the scientific basis. So we reviewed existing literature and we are actually writing right now a paper. And these figures will actually be part of this paper. And then we worked with the members to kind of formulate some recommendations on what we should do next. It's a very contentious topic, so we've seen a lot of disagreements. So what I'm presenting right now is the things for which there was the highest level of agreements between the participants. And so we identified three main challenges. The first one is knowledge gaps. And that's, I think, the first thing to communicate on the topic. We don't know enough. We don't know if it works. We don't know what could be all the cascading and long-term effects of these techniques. And our recommendation for that is to conduct more research. There is a bit of disagreement in what we call research. Some people say it should be mostly lab research. Some other people say we should also do some field experiments. And even the scale of what we call a field experiment is heavily discussed. The goal of this research would be to better understand the potential benefits it could have, but also, of course, the risks and the social and ecological impacts. The second challenge that we identified, despite the uncertainty, we know that there are some risks. So it's not because we don't understand everything on a topic that we don't know what can be some of the risk. A risk is always uncertain, actually, by definition. So we know that some of these approaches can be risky, can have some deleterious social and ecological impacts that I mentioned a bit earlier. And so our recommendation for that is to limit deployment, or even sometimes to say field experiments, to their bare minimum. And when I say minimize deployments, I'm talking not even about current deployments, but even about plans. In any case, we should plan to do as little as possible of this. And that's very important. So what it means is that we have to decarbonize. And that's, I think, the main conclusion that we always reach, and everyone agreed on it. When we talk about climate change, we have to talk about decarbonization first. And carbon dioxide removal should come after, if it's safe, if it's understood, if we have the resources for it, and all things like that. And the last thing that we wanted to communicate, the last challenge, it's quite a big one as well, is on governance. And Martin will say a bit more about that later. we don't have right now a proper governance system, a proper governance framework for mCDR. So even if it's starting, as I will explain a little bit later, there is no overarching international regulation dedicated to it. So it's a big risk because it means right now a bit everything can happen, which can be quite risky. So recommendation for that is to strengthen existing governance framework, but not only to strengthen it, to do that in a way that is inclusive of civil society, of local communities, but also of indigenous communities who have very special relationships and rights when it comes to nature and the ocean. So that's it for the three main challenges. And for my conclusion, I would like to ask a question and to try to answer it as best as I can, on the urgency to focus on mCDR. So why is it urgent actually? If it's not ready, why should we focus on it? The first thing is it's because it's starting. There are already some investments that are being made. You can see here on the right a map of field experiments. And that poses the risk to divert the attention, like political and public attention, away from decarbonization. So if we have the promise that we are able to capture CO2 using a magical solution in the ocean, it will it will release the incentives for people to make some efforts for decarbonization. And so that's what we call a moral hazard. And for us, it's one of the main risks of the promise of marine geoengineering, or mCDR. And the second thing is, as I was saying, field trials are already starting. So yes, it could be important for scientific research, and even aside from the understanding of mCDR, I mean that could be interesting also to better understand the ocean and all the processes. But it comes at the risk of having ecological and social consequences. So we really try to insist on that. It's starting, and it's very risky. So we have to be careful with what is done. And for that, we need some shared position. And so that is my main conclusion. So far, a lot of organizations do not have a position on the topic. So far, the general public doesn't know a lot about the topic. And so we need to communicate on it. We need to understand it, and we need to have shared position to make sure that whatever way we go there as safely as possible for the ocean, for nature, and for humans. So that's it for me. I'll leave it to Martin, and happy, I think, to take some questions at the end. Thank you.
I hope you can all see my screen. Thank you very much, Victor, for this exhaustive overview of the different marine carbon dioxide removal techniques and the many uncertainties that we have with them. So I will focus mostly on marine geoengineering techniques on my side. So not addressing coastal ecosystem restoration, which has already a more, I would say, defined frameworks and more technological and readiness, I would say. So, as Victor showed, we're talking about interventions that could fundamentally alter ocean processes with still a limited understanding of their ecological and social impacts. So, I'll try to complement Victor's scientific insights with how international governance frameworks are currently addressing these emerging geoengineering issues. Because at the moment, we already have, as Victor said, policy decisions and industrial applications that are already being discussed and including mostly at climate COPs. So let's take a look a bit at what's already in place. And the first, I would say, framework that we do have on these geoengineering activities is the London Convention and its protocol. So basically, it's the most explicit, I would say, framework that we have targeting marine geoengineering activities. And in 2008, parties agreed that ocean fertilization activities should not be allowed except for legitimate scientific research. And that's a distinction also that Victor brought to the debate. There's a clear distinction between scientific research and investments and industrial application, and proposing marine carbon credits based on these techniques. And in 2013, they also adopted a formal amendment to this convention to regulate all marine geoengineering techniques. However, this amendment still lacks sufficient ratifications to enter into force. So I would say it's the clearest legal basis to control these marine geoengineering techniques, but it's not yet fully operational. The second one that we have is the Convention on Biological Diversity, and it's very interesting because it targets specifically biodiversity. And this one also in 2008 called for a moratorium on ocean fertilization. Every time we have these ocean fertilization techniques as the first step for regulating these marine geoengineering techniques. And in 2010, this moratorium was extended to all marine geoengineering techniques. So this CBD's approach is also deeply grounded with the precautionary principle, which is a very key theme when talking also about marine geoengineering activities. And we can see that from the Victor presentation also, which is that we should avoid large-scale interventions when scientific uncertainty and potential harm are high. So this problem with this moratorium yet also is that it's non-binding, so it mostly relies on state voluntary compliance. And but it mostly underlines that manipulating large-scale ecosystems also is incompatible with biodiversity protection. Then we can't talk about protecting the ocean without mentioning UNCLOS, so the UN Convention on the Law of the Sea, which provides basically this broad legal foundation for all ocean activities. And its main goal is mostly to balance the rights and duties of states about navigation and resources, but also to protect the marine environment. So it does not directly mention geoengineering, but it imposes a duty to prevent and control all pollution. So it could, in theory, also apply to marine geoengineering techniques that alter the chemistry or the ecosystems. But this one is a more broad framework, but it's been supplemented very lately by the BBNJ agreement also, which is the most recent framework that we have, which was adopted in 2023 and entered into force after being ratified last September, and will enter into force in 2026. But it aims to conserve marine biodiversity in areas beyond national jurisdiction. So basically, it has very strong link also with all these marine geoengineering activities. And this treaty also specifically mentions the precautionary principle and also introduces environmental impact assessment for activities with potential harm. So the question now to know if BBNJ is going to be an efficient tool or not regarding marine geoengineering activity is to know whether marine geoengineering activities will fall under the activities that need these environmental impact assessment requirements. But if so, the BBNJ treaty could be a very key tool to prevent risky activities and industrial activities in the high seas. And lastly, because it's the one we had to has a very key topic link with these climate activities, it's UNFCCC with the upcoming COP in Belém that started today, as André was saying. And it's the one that will be in the news for the next 2 weeks. And this one governs the global climate response. So this framework mainly focuses on reducing greenhouse gas emissions, but also recognizes these potential roles of CO2 removal. Thus, we can have sometimes in UNFCCC framework this climate-oriented bias that can sometimes overlook also the biodiversity dimensions of the proposed activities. So this creates sometimes a governance gap, I would say, for marine geoengineering. And that's where marine geoengineering industries are pushing a lot also, emphasizing these climate benefits that we could have with marine geoengineering activities, but overlooking these uncertainties and biodiversity and social risks that we also have with these techniques. So sometimes we can have, I would say, ocean-based interventions that might be pursued under the banner of climate actions, but that can threaten biodiversity. So UNFCCC could really need to be very more careful about these climate solutions in the ocean. So basically, this is a broad overview of this legal landscape that we have on marine geoengineering. As you can see, very fragmented. London Protocol that explicitly regulates marine geoengineering, but that's yet to be entered into force, CBD that provides this, I would say, precautionary stance on the matter, BBNJ, sorry, that could soon offer a very operational tool, but depending on whether or not we have marine geoengineering in the discussion for environmental impact assessments, and UNCLOS that offers general obligations, and UNFCCC that remains, I would say, somewhat ambiguous on these ocean dimensions of marine carbon dioxide removal. So altogether, we have this bit patchwork, I would say, that leaves many gray areas for potential non-scientific industrial interventions at sea, aiming to deliver these carbon credits to compensate anthropic emissions. So maybe we'll also need to put this in relation with two key definitions that needs to be addressed when talking about marine geoengineering. And the first one is the precautionary principle, and I've mentioned it already a few times in my presentation, but this is a principle that's very key when discussing these techniques. And it's been defined already in the 1992 Rio Convention. And it clearly states that when an activity poses a threat to the environment or to human health or to human society, we need precautionary measures to be taken, even if the cause and effect relationship isn't fully proven. And that's a very important point, I think, also. And so the burden of proof lies with the actor proposing the activity, not with the public or the regulators. And this principle is very deeply rooted in both the CBD, the BPNJ agreement, UNFCCC, also the London Protocol. And so if correctly applied with marine geoengineering activities, it dictates to prevent, I would say, economic and industrial activities based on these techniques in views of the associated risks that Victor has been presented. And same goes also with the concept, I would say, of nature-based solution that's being sometimes linked also with these marine geoengineering techniques. Nature-based solutions need to be working with the ecosystem. So it really strongly applies to the techniques that Victor has been presenting about restoring coastal blue carbon ecosystems like mangrove, like seagrasses or wetlands to enhance their carbon storage and their resilience. But on the other hand, when we talk about marine geoengineering that seeks to engineer really this ocean biogeochemistry with this technological manipulation, we deeply modify natural processes, and thus we cannot be categorizing them, as I would say, nature-based. So maintaining the real meaning of these two definitions will also, I think, be a key point when addressing these marine geoengineering debates. And finally, it's also being a point that's been discussed in this policy brief that we've been releasing with BlueRemediomics and Biocean 5D, especially with the inputs of University of Aberdeen, who's taking part in the BlueRemediomics projects. But I would like to conclude maybe on some ethical considerations. First, the need to recall that nature is a cycle. Carbon is a cycle that was already there in place before these anthropic, I would say, excess carbon release into the environment. So there's a strong need to think these techniques with this One Earth approach to quantify what's being stored, but also what's naturally being emitted and what needs to be reduced being emitted in excess. And most importantly, before this COP30, we should also ask ourselves, I think, about to what extent should we again force nature to compensate the fact that we didn't reach our climate targets. And marine geoengineering is the latest fix that's being proposed, but we have seen already many other techniques that and technological techniques that have been proposed. And the safest, and it's actually the main philosophy in the Paris Agreement and the most ethical path, is to remain reducing greenhouse gas emission and to restore natural ecosystems. So keep reduction a priority is the key point that we need to address. And every time having this technological proposal being pushed at every COP is also delaying these reduction objectives. So I would say to conclude, it's kind of deep sea mining all over again. We're engaging in industrial commercial activities where science is still needed, overlooking many risks and uncertainties that science has identified. Thank you very much for listening to us.
Thank you, Victor. Thank you, Martin. Now we can ask the attendees to ask questions in the Q&A. And in fact, Martin, I think there's one comment that is directly addressed to you. I'm not sure if you've seen it, or should I read it to you?
Yes, I can see it. So from Jean-François from IUCN. So I would think it, I'm taking the time to read it just before answering it. Yeah, I think it strongly relates to what we were saying, and it's very interesting because it was the same for the Tara Ocean Foundation also, and that was a point that was raised by Victor, the need for many institutions to address this topic, and it's being discussed actually very recently this year, and it was the first year that we've been working on it with Tara and with all the scientific consortium that we've been working with, and it's great to see that IUCN also proposed a motion. We all know how important IUCN motions can be to promote and to push for a political decision. So seeing that they also made these statements on the geoengineering is very encouraging, I would say.
Thank you, Martin. Thank you, Jean, for your question. Are there any other questions from the audience? If so, please do write them in the Q&A. I see Chris has raised his hand. I'm going to give me a second. There you go. You should be able to talk.
Okay. Can you hear me okay?
Yes,
We
we can.
can.
Very cool. Okay. I just want to propose a intellectual exercise of reverse engineering. You talk about the precautionary principle being in place since 1992 only, but in fact, if we had the precautionary principle in place before that, there wouldn't be any cars on the roads. There'd be no trains, railways. There would be no use of oil and gas and fossil fuels because it's too risky, right? So don't you think it's a little unfair that the politicians and society ask us to apply the precautionary principle to problems that had absolutely no consideration of the precautionary principle in the first place? Thank you.
I can take that one, Chris.
Good.
No, thank you, Chris. And first thing I would like to state that we worked with many scientists for this policy brief. You're just seeing the QR code to download it in the center. We worked with many scientists. We made a workshop in Galway with local partners, and then there's a different vision from scientists about how we can continue to making research to find a good solution for enhancing ocean mCDR. But what we do think, Chris, is why the precautionary principle is important here is because the carbon market is now being relaunched since two COPs behind us, since Glasgow, basically. There is a whole system to offset the emissions. And we saw yesterday the EU increasing the offset percentage to 5%. So there is a real run from startups and opportunistic organizations to make money with that. So this is the reason we understand that we should keep the moratorium, the embargo, and to allow only mCDR in research finalities with a limited scope and space for its realization. Mainly, we don't want to repeat the mistakes we did in the red mechanism in the under the Kyoto Protocol, where we saw many organizations claiming carbon sequestration projects by planting eucalyptus forests in Brazil, for instance. I'm from Brazil. I saw many projects making money with that. And then the externality for land, for water, for soil was disastrous consequences. So I think we are feeling that the push for mCDR now are coming not from scientists, but from the economic sector, from private sector, from startups. So I think we should keep the vision that we must apply the precautionary principle, and we should limit to research the techniques that are being presented. But I understand you as a scientist, Chris, the liberty of research and the freedom of research is also a value we defend in the Tidal Ocean Foundation, and it's a balance between the benefits and the interest for research. But for now, as a political momentum, I think it's important to keep the precautionary principle, as we are seeing the private sector stepping in.
Okay, thank you.
If I may just add a little something, André. Well, personally, I could live in a world without oil and gas, and I think we will have to at some point. But joke aside, I believe that the precautionary principle is a principle. So it means that it's something that should guide our decisions with other things in mind, always. There are always other principles that we should consider for anything. And so, of course, an absolute and strict application of the concept is impossible. Otherwise, we wouldn't step out of our homes, we wouldn't eat, we wouldn't do anything, because it can. But I think, well, as André was saying, it's important both for research and potential deployments to consider, because it could have large scale impacts, and because of that, we should have it in mind at least, and then we can get into more technical discussions about what level of risk do we accept or not, what potential benefits and everything. That's when the discussion becomes more technical. But having this principle in mind, I think, and not reversing it or forgetting about it is crucial. Even us as researcher, we have this responsibility to bear it in mind.
Thank you, Chris. Thank you, André. Thank you, Victor. Martin, can you please show again the CBD slide, please, and maybe say a few words?
Can you see it now?
Yes.
Yes. So two key milestones for this CBD.
Martin,
It's
it
gone
disappeared.
Yeah.
I'm having the same problems as just before, so I'm going to do it this way. Is it good this time?
Yeah.
Yeah.
But you can. Okay, good. So yes, two key points on the CBD slide. So this conventional biological diversity. So yeah, it's one also of the key moratorium that we have on this ocean marine geoengineering techniques. First, it came with ocean fertilization in 2008, and again in 2010, it became broader, just like the same scheme, I would say, as the London Convention. But it's mostly voluntary, I would say, engagement from the different states and voluntary compliance. It's mostly non-binding. So it's interesting because it brings separately from UNFCCC, so from climate COPs. It brings this dimension, and having in mind also the impact that it can have on biodiversity as a whole, and that's the way it's been discussed at the Convention on Biological Diversity. But it's a strength that we have regarding these techniques, but also a very strong weakness as it being mostly non-binding. I don't know if you want to have a word also, André.
Yeah, just to complete it, I was in the last COP of the CBD in Cali, where states agreed on what we call the Fondo Cali, the Cali Fund for Biodiversity. But actually, les caisses sont vides, as we say in French. There's no money in this fund for now. So I was really impressed by the quantity of side events and panels working about blue finance, blended finance, blue bonds, blue derivatives. There is a big push for blue finance in this moment inside the CBD to feed the Cali Fund for biodiversity. And this is a bit the danger here. We have also for the Climate Fund, and we have the same stuff for the BBNJ Special Fund for the high seas. So states don't have money now. The political momentum is very complex. And so these techniques which came with private money and from market-based solutions are timely because les caisses sont vides, because we don't have money. States don't have money to put in these funds. So states are accepting the idea of blended finance, and we are not saying that it's not needed. We don't want any blended finance, but the fact is that we are seeing more and more proposals with market-based solutions for nature, and this is must be analyzed with science, with assessments, with time, because it's not the level of confidence and readiness of these techniques are still not there.
Thank you, André. Thank you, Martin. I don't know which one of you guys, there is one question in the Q&A. How can we distinguish between natural blue carbon sequestration and human-enhanced geoengineering efforts when accounting for carbon credits? I don't know who wants to take this one.
Maybe I can start a little bit because I was mentioning that in my presentation, and if I want to say more about it, you can after if you want. It's a great question, actually. Thank you very much for asking this. It's very difficult, and not only even the sequestration itself, but just the fact that there are movements of CO2 between the air and the ocean and within the ocean. So the ocean moves a lot, CO2 moves a lot within the ocean, or it fluxes. So it is very difficult. The way to do so is through what we called, and I very briefly mentioned in my presentation, what we call monitoring, reporting, and verification, MRV. But again, it's very difficult. So one of the ways to do that, but not even the way, but the general concept is to be able to prove that our activity has been causing more CO2 capture than what was already happening, if there was any. And so I think that would be different for any technique, but so far it's really on experimental stages, and it usually relies on modeling. So that's an issue, because if we rely on a model to say that we capture this amount of CO2 without being able to prove it with actual data, that can be problematic because it's never completely sure. So that's my take on it. And so I would say that right now, the carbon credits that are already being sold, even if they are presented as being highly reliable carbon credits, I would tend to say that these are not so reliable, because mostly, again, based on models, to the best of my knowledge, at least.
There's a follow-up in the Q&A from the same person. That is, do you maybe want to talk? I can give you the floor if you want. Let me just, there you go. You should be able to talk. We can't hear you, unfortunately. Do you maybe want to follow up, Victor?
Yeah, it's fine. Maybe this person doesn't want to talk or they can't. So it's perfectly fine. So yeah, your research is looking into blue carbon, basically, we could call it. So I think that's quite interesting because it's all about the scales we are talking about. So here we are talking about a lagoon's ability to act as a natural carbon sink. So that's raising all the question. If we think about the whole ocean as a natural carbon sink, I would like really to distinguish two things. The natural capacity of the ocean to capture CO2 that has always happened, I mean, since there have been marine ecosystems with phytoplankton and plants. So yes, the ocean can, in some condition, capture CO2. But let's just remember that in the past 10,000 years, we've had a CO2 concentration in the atmosphere that has remained very stable between 260 and 280 parts per million. So let's just remember that the ecosystem back then was quite healthy. We weren't emitting so much CO2. It was quite natural, quote unquote. And yet the ocean was not capturing more CO2. I mean, it was capturing CO2, but it was also releasing through other processes. Let's think, for example, of volcanoes. So it was, and it is still a flux. So that's the natural carbon sink. Some is captured and some is emitted. That's the natural process. Then the second thing is that the ocean captures some anthropogenic CO2 emission, meaning that if we emit right now 38 gigatons of CO2 per year, a part of it will go in the ocean, meaning that right now the ability of the ocean to capture CO2 is only based on the fact that we still emit CO2. If we stop emitting CO2 after a little while, the ocean will stop capturing CO2. That's very important to remember. And so when we look into blue carbon ecosystems that are at the equilibrium, it should actually be still, I mean, it should be at an equilibrium. And so that's why mCDR is a thing, because the goal is to enhance this based on very specific and targeted action. For example, restoring an ecosystem that was damaged. If the mangrove that was here disappeared, then it's lost an ability to capture CO2, and it probably emitted CO2 back in the atmosphere. So that's something very important to remember, the natural carbon cycle versus the anthropogenic emissions that we are putting on top of what is already present in the atmosphere, and then what we are trying to do to try to improve this natural carbon cycle. And one last thing I already mentioned, but it's quite important to remember as well, is that if we damage more marine ecosystems, the ability of the ocean to capture CO2 could be decreased. The same with climate change. It could reduce, for example, the phytoplankton productivity, and then in which case it could diminish the ability of the ocean to capture CO2. And actually, in some other cases, it could increase this productivity and increase the ability to capture CO2. So it's all very complicated processes because we talk about cycles, about CO2 emissions from humans, about natural CO2 present in the atmosphere and the ocean. But yeah, that's the kind of the few points I wanted to make on the topic.
There's a follow-up from the same person.
So I would have the same answer. It's uncertain. And so the question, sorry, is how do the geoengineering intervention or mCDR intervention interact with natural blue carbon? It's uncertain, but one of the fears that we have is that geoengineering could actually have an impact on blue carbon processes. And so, for example, let's say ocean alkalinity, if, and I'm talking about the if because I'm not sure it has been ever proven, but if it was toxic to phytoplankton, then it could diminish the ability of phytoplankton to produce CO2, to capture CO2, sorry. And so it could release CO2 back in the atmosphere. So that's one of the fears that we could have with these techniques, is that the goal of these techniques is to interact with natural ecosystem processes, because it's only through an interaction with the process that we could capture more CO2. And that's at a very, very large scale, because the quantities of CO2 that we're talking about is just as large as the amounts that we have been emitting through all the oil and gas industry that we've been creating in the past years. And so that's important to bear in mind. The goal is to affect ecological processes on a very large scale. And so part of these processes, of course, could be the capture of CO2, while it's quite uncertain, I have to say.
Thank you, Victor. Charlotte has a question about deep sea mining. Do you plan to raise this issue with the state at the COP? Any high ambition coalition initiatives, such as those for deep sea mining, being considered?
I can say on Tara's side first, but maybe Victor, then you can say what you've been doing with the Ocean Climate Platform on the matter. But for the moment, there's no high ambition coalition initiatives, as the subject is really rising very recently, and we've seen the time it's been taking for deep sea mining to create this coalition and this willingness and this momentum to have states gathering around the subjects and committing to it. So there's also, compared to deep sea mining, we already have some, I would say, partial and weak maybe frameworks, but we do have things that we can build on for the moment. But it's something that we want to address also for general public, trying to raise this subject with general public also, and we'll be discussing it a bit with André at Ocean Virtual Pavilion at the COP. But for the moment, there's no high ambition coalition initiative being planned on the subjects, because many states actually do already have these frameworks that they can engage into, like, for example, this moratorium, or like the protocols of the London Convention, where they can engage and ratify to make it happen and to prevent industrial and economic geoengineering to happen.
Yeah. I could add, Martin, just that it's complex to have a high ambition coalition on this matter is very complex, because small states are looking forward to alternatives to fund their environmental protection, especially to fund MPAs, with this kind of funding coming from blue market, blue bonds, blue finance. And one of the possibilities is that blue carbon ETS market-based. So it's hard to join as for deep sea mining, as for the BBNJ agreement, because states they don't want to prevent the hypothesis to be funded by this mechanism in the future.
Victor, would you like to add something?
Yes, I could, actually, from OCP's perspective. And I fully agree with everything that was said before. Thanks a lot. That's actually a great question, and I'm afraid that I don't have an answer yet. I wish I could tell you this is our position and this is what we should do. We are still in this phase of gathering people and trying to understand what we should do together, what can be a relevant position on the topic. So this is really an open call to everyone working even remotely on ocean, climate, biodiversity topics, to read more on the topic and to try to join forces into thinking about it collectively, because we will really need that before any strong position can come from civil society, because we need to be able to talk about it in a way that is informed by science, but also understanding all the ethics of these questions, and keeping in mind the things that are the fact that things are moving very quickly. So I really hope that at some point we can have this collective position and go to COP and say, okay, this is what we have to do, and go to states. But so far, it's a bit more complicated. And I think the best thing we can ask to states so far is to get informed on the topic from a variety of perspectives, trying to listen a bit to everyone and civil society what we have to say on the topic. And I see. Can I answer the next question very quickly, or do you want to?
Yes,
Okay.
go ahead.
So I'll try very, very quickly, because it's a hard question, and thank you very much for asking it. My answer will be disappointing. There are a lot of different mCDR techniques, and I think for each technique, there will be a different method to assess the impacts. It will come to understanding like what could be the species that are affected, counting the fish, if it's the fish that could be affected, counting the plankton. But in any case, it will all come through looking at what's happening in the place where the technique is happening, and not only in the very short term, but as long as possible. So what we are talking about is also long-term impacts, and that will be different for each technique.
Thank you, Victor. I think we can take the last one, and then that will be all. I think this is either for André or for Martin.
Well, it mostly depends on what blue carbon techniques that we are talking about, because I think that Victor has been presenting it very well at the beginning of the webinar, but it depends also on the technological readiness and how much the methodological techniques that we have to quantify also the carbon that's being stored is reliable or not. So it's depending also, but we still have to push a lot for science to produce relevant way to quantify and to measure how much carbon is really being stored, to what extent it can be stored also on the long term, also if it's released in a few decades or not. But yes, I think on our side, key policy recommendation is going to be investing also on science in the upcoming years, most importantly on these techniques that we do not know as technologically reliable for the moment. I don't know, Victor, if you have any key recommendation, but it's a very new subject, as you were saying in your presentation also, Victor. It's also all being discussed and discussed at the moment. So that's why we're trying to work with the entire networks of scientists from the Tara Foundation and from the related projects, etc., to try to build these recommendations and these policy recommendations. Yes.
Yeah, I don't have anything to add. It's something we need to scrutinize more and keep an eye on.
All right, I think we're going to close the Q&A session. Emma, do you want to take it over?
Yes. Thank you, everyone, for joining today and for contributing to this insightful discussion. If you still have some questions that were not addressed today, please feel free to download our policy brief. This policy brief was coordinated by the Tara Foundation. So please keep in mind that its content does not necessarily reflect the views of every single partner. This webinar was also recorded, so you may find it later on the English-speaking YouTube channel of the foundation. Thank you to our speakers for sharing their insights, Victor, Martin, and André. Also a special thank you to Amandine and Emil for helping organize this webinar, and to our partner projects, BeOcean 5D and BlueRemediomics. In just a few minutes, we'll move into a dedicated slot with the press. So I kindly invite all of you who are not part of the media to leave the Zoom meeting at this time. Thanking you once again for joining and for your engagement throughout the webinar. Je vais passer en français pour